Hello, everyone. Hope you're enjoying yourselves. We're very excited for this moment. We have a brilliant person in our presence, a great mind, a distinguished technologist. I love that title. From HP 3D printing software, I would like to introduce Scott White.
Hi.
Hi.
Hi, everyone. Can you hear me? Okay. I'm going to talk to you about a new industry organization that's really aimed at enabling and supporting innovation in the 3D print workflow space. It's all software, so there's no hardware. The talk is a little technical, so I hope you hang with me, and if I see people nodding off, I'll move along. So first, I work for HP, but I'm not talking as an HP employee. I'm really representing the consortium. And the consortium was formed fundamentally to create a new file format for 3D printing and manufacturing. And when we talk about this, the first thing we get asked all the time is, well, why do you need a new one? Why would you need to do something different than the millions of formats that are out there today? And fundamentally, it's because the things that are available today don't meet the needs of what we're trying to accomplish. There are manufacturing formats. The traditional format is STL. It was invented in 1989 or 1988. It was designed to do one thing. It was designed to describe a mesh. But it doesn't have some key information about manufacturing that we need to have going forward. It doesn't even specify units, for instance. So oftentimes when you open an STL in a tool, it'll ask you, are these inches? Are these centimeters? Are these millimeters? And depending on what you pick, you can end up something with for the size of an elephant, or you can end up with something the size of a thimble. So there are basic things that are missing in there. On the other hand, there's a new standard that has been developed over the past several years called AMF. It hasn't gotten a lot of traction for a number of reasons, but one of the reasons it hasn't gotten a lot of traction is that it has some complexity to it that makes it very difficult to implement. And so people were not doing that. There are lots of CAD formats. This is the fundamental building block of design. But they don't serve the manufacturing and 3D printing space very well either, because one, they're very complex, and the software you need to actually interpret them accurately is very hard to write. In fact, between CAD applications, it's very difficult to move models and have them look the same. So there's some interoperability issues. Also, they don't do a good job of describing very, very fine geometries, so they can get very, very complex. And finally, there's a whole bunch of formats that you see, I'm sure, in a lot of the booths here around rendering and visualization, and these are formats that were usually generated out of the animation or gaming or graphics industry. They're things like VRML and OBJ. They carry a lot of information, and they can do things in a very nice-looking way, but they don't always meet the needs of manufacturing in terms of geometric robustness, and they certainly don't carry metadata and other things that we need to actually drive the printing process. So, as we were looking around, in fact, before we formed the consortium at HP, we were inventing our own manufacturing format that served some of these same needs. But about 18 months ago, there was a group of companies that started to get together to talk about what we should be doing. And at the time, Microsoft had already been leading out on sort of creating a new format that they call 3MF. But it was closed. It was part of the Windows ecosystem. And they were asking many of the people on this screen individually what they thought of the format. And I was one of those people, and I told them, I said, well, it looks fine. It meets many of the needs that we've actually been trying to get figured out, but there's no way we're going to adopt a Microsoft standard. We've been there before in lots of other spaces, and it ends up being a disaster. So they decided to start a dialogue with other companies in the industry to figure out if there was a better way. And last winter, or no, a winter and a half ago, or a year and a half ago, they finally came with a small group of people, us, a company called NetFab, which is now part of Autodesk, SLM, and Dassault, and said we should try and get together and actually make this fly. And so we did all the legal wrangling and actually got the consortium formed in April of 2015. And since then, we've added several new companies. And really, the key here is that we wanted to have the right representation from the right parts of the industry. So we have all four, in fact, I'll go back. We have all four of the major CAD vendors in the market today participating in the consortium. We have Dassault Systems, which represents both Dassault and SolidWorks. We have Siemens, we have PTC, and we have Autodesk. So all the big guys are in. from a design perspective. In terms of 3D middleware, we also have the major players. We have Materialize and we have Autodesk, which acquired NetFab about, I don't know, 6 months ago or 8 months ago. And then finally, on the hardware side, we have all the major players, or most of the major players in the 3D printing space. We have 3D Systems, Stratasys, SLM, HP will be a major player soon, and Ultimaker to kind of represent the consumer market. So we feel like we have the right mix of companies and the right mix of interests and the right mix of points of view to really make this thing go. In addition to that, we wanted this to be a completely open format. It is freely available. You can go download the specs today. There's no cost to using the specification. There's no licensing around the use of the file format. You can use it as an input format, as an output format. You can do whatever you want with it. There's a framework around how the consortium works and how the specs are managed through the Joint Development Organization, which is, you can see the URL here. You should go check it out. So there's a legal framework around the whole thing. And then finally, we're providing open source today for the core specification, and we'll continue to do that for extensions that are coming in the future. And this is free for anyone to use. It's a cross-platform implementation. You can go get it. We're actually starting to build out a repository of sample files so that you can test your consumption of 3MF. And we're also starting to work on test infrastructure for producers so they can generate files, send it into a service, and know that that file that they're generating is valid, right? So the key here is that we want to basically eliminate barriers to entry, and we want to make sure that we can get people on board and adopting the standard as quickly as possible. And just as a few examples, so I mean, it was a Microsoft standard to start with, but it is now a native part of Windows 10. So if you have a 3MF file in Windows 10 and you look at it in the Explorer, it'll actually show you a 3D thumbnail of that, and when you open it, or when you double-click on it, it will open in the Microsoft application. So it's a first-class citizen in the platform. Autodesk and the NetFab products inside of Autodesk, as well as other products from Autodesk, are already supporting 3MF from an input and from an output perspective. And HP is actually supporting 3MF as the native print format on the first printer that we're going to ship later this year, which is the first hardware in the market to actually support it as a native format. So we're really excited about it, and we're excited about it because we feel like it sort of provides this end-to-end solution that we've all been sort of craving in the industry. And I'll talk more about that in a minute. So in terms of the design considerations for the format itself, there were some things that we really wanted to make sure we hit. One is that we need it to be complete. So everything you need to know to manufacture or fabricate an object or a set of objects in a 3MF container is within the container itself. You do not necessarily have to send along an email or a note or a sticky with the file to send to your provider or your model shop guy or anyone else to say, this is what I want to happen. The format itself specifies everything. Units. We'll get into the extensions around color and materials and so on. So it's encapsulated. It's also compact. So all the files that represent 3MF package go into a zip file. And what I've seen in my testing over the past year or so is that I've yet to see a 3MF that's larger than an STL, even a binary STL. So and oftentimes it's 2 to 5 times smaller than the equivalent STL. And there's some reasons for that. One is that we don't duplicate or triplicate every single vertex in the geometry, which I'll talk about in a minute. But also just because of the way it's structured and that we're actually using a high compression algorithm to compress it helps as well. And then finally, it's XML based at its core, which some people love, some people hate. It is what it is, but it's also human readable, so you can actually tear a 3MF apart and go look at it, and it's fairly easy to tell what's going on. And then for things that are not part of the XML itself, we only use standard formats like PNG and JPEG to represent textures and other things. So in terms of the structure, because it's an open package convention-based file format, we have a root, and then basically the models follow from that root, and then each of those models can reference other resources like thumbnails or textures that will be applied to that model. So it's very much a container approach where you can have lots of resources and leverage those resources very easily. Also, even more importantly, is that we all recognize that the 3D printing industry is young. We recognize that a pure mesh geometry for representing objects in the future is probably not the way it's going to be. And so the idea is that we wanted to make sure that the standard was extensible. And that is done through very simple mechanisms that XML supports today, just using namespaces. So you can take any content you want, you can insert it anywhere you want inside of the existing structure of the file, and you reference that as a different namespace, and you can pretty much do whatever you want because the extensibility points are all built in. And as an example of that, shortly after the core specification was ratified, we have also provided a material and property extension which does exactly that. It's independent, but it can be easily integrated, and I'll talk a little bit more about that in a second. And then finally, from a geometric perspective, I know this is a little bit geeky, so I'll try and keep it short, but the specification demands that parts are manifold because of the way they share vertices and edges. And there is a specification for how the vertices have to be oriented to allow the correct normal orientation in the part. And even when we do have self-intersections and overlaps, because of the way the fill rule is applied, those things are not ambiguous. They are unambiguously processable, which is not the case in other formats today. So that's kind of the baseline. If we look at the actual how we view 3MF being used in the real world, it's a very broad picture. So for instance, today, it's very easy to be able to use 3MF with a desktop printer because Windows supports it today. If you have a driver for a printer, you can actually do this today. Design application, Windows print system, file print, go. SolidWorks supports this today. But this isn't the common 3D print experience that we expect to have happen, right? And certainly most of the people inside the 3MF Consortium are much more interested in industrial or commercial uses. So we also want to extend the use cases out to support more distributed flows. So one would be something like Shapeways or iMaterialize, where you are just basically sending a file in to be printed by somebody else as a consumer. And we see 3MF being used there both as the input format, so you export it from your design application, and then all the way along that tool chain until it actually gets to the printer. And there'll be variations on this, and this is sort of a future vision. So it may be that today the file goes all the way through as a 3MF, and then it goes into some printer-specific format for an existing printer. So maybe it gets sliced into CLI or some other format. But effectively, all these other workflows are very similar, even though the environments they operate in are very different. So in the internal model shop, if you have a 3MF and you can describe everything that needs to happen with that part within the package itself, then it's a much more easier conversation with your model shop operator than if you have to do it through email or whatever. And then same with Service Bureau. So we see and we intend that 3MF can support all these different parts of the workflow. All the way to the printer, ideally, but that's not necessarily a requirement. And so in terms of the overall ecosystem and how we're viewing it, we really wanted to push this idea that there can be one format from the design application to print. That does not mean that 3MF is intended to go into the CAD space or into the rendering space. It's really sort of a one-way street from when you're ready to enter a printing or manufacturing workflow in your application, you basically then export it to a 3MF with the information that you need in it, and then it passes along through that. We wanted to make sure that as we build out the members of the consortium and we start to get adoption within the industry, that we are driving that adoption. So right now, I can't talk about too many things because they're not public yet, but virtually every member of the consortium will be announcing support for 3MF in one way or another within the next year. And it's really a question of kind of product timelines. But people are engaged and people are implementing today. And then finally, we are already working on new extensions. I'll talk about a couple in a second to the base format because we recognize that there are needs that are not being met by a pure mesh format today. So there are two new extensions actually that were just ratified this week, and they'll be published on the 3MF website sometime in the next few weeks. One is a slice extension. So most printers operate on slice data today. Our printer does this as well, HP's printer. So the slice extension enables a vector-based slice format. It integrates neatly and cleanly into the existing infrastructure inside the file, so it's referenced as just another object. And then all of the same material and property and color information is basically inherited by that structure. So it's a clean integration, and it actually sits side by side with the mesh representation in the file. The second extension that was ratified this week is called the production extension, which is kind of a weird name. It's actually my fault. So there's two things here. One is we wanted to make sure that as we start to ramp up the use of 3D printing in manufacturing or in environments where you want to have track and trace, that every element inside the file is trackable back to its source, so that as it goes from an application through the printing process, when you close that loop from a sort of a fabrication perspective, that you can always know which build it was, which part it was, which model that part used to actually generate the physical object, and then if there are assemblies, how to identify those assemblies in the file as well, which 3MF supports today. So that's part of it. It's just really about track and trace and making sure that everything is uniquely identified. And we're actually implementing against that right now. And then even more importantly for the industrial use cases, that the production extension allows you to reference other files that contain models instead of having everything monolithically defined in a single XML. So instead of one big huge file that represents, say, 100 objects or 100 parts, you can have one small file that basically references 100 other files, and those things can be independent. And this is important for a couple reasons. One, if you have a build platform that maybe has 1,000 parts in it, and it can be maybe 700 megabytes or more, parsing 700 megabytes of XML is not trivial. It can be a very significant challenge. And secondly, if you have 700 parts coming from 700 people, if you have to open up that geometry and concatenate it, it's more prone to error. So if you can take in 3MF files from other people and basically just pass those through and create another package with the same geometry without having to touch it, there's a huge amount of value in there, because that means you're not messing with numbers, you're not making floating point errors, etc. So it helps us to not have to touch geometry again. Both of those are, like I said, they've been ratified this week and they'll be getting published sometime in the next few weeks. So, what does all this mean for 3D printing users? And I've talked about this a little bit, so I'll kind of go through it quickly. But for desktop users, it means you can easily enable CAD to print workflows. If design applications support the ability to use, in particular, the Windows print subsystem, then this is a seamless process. And even more importantly is that because of the way the format is defined, we can get away from a lot of the existing STL errors that we have today, right? It's not going to fix all the errors, and there will still be bad geometry, I can guarantee it. But the specification enforces a much more rigor than the existing formats in the market today. And then if you're a print service user, it's compact, so it's easy to send. It's also complete and encapsulated, so you don't have to send a lot of extra information with your part when you send it up to the service bureau. It is actually sufficient to specify color parts, to specify figurines and things that are basically 3D geometry with a 2D texture wrapping. And then for professional users, really the intent here is that we can do a container, so you can actually manage multiple parts within the single container or a single file, and then you can extend it however you need. So for instance, if I have a special something that I want to put in a 3MF file that represents a piece of geometry or a piece of metadata about that geometry, because it's an extensible format, I can easily do that. And if it's in my ecosystem, then it's fine. And it doesn't impact the validity of the baseline file. I can still open that 3MF in any tool that's 3MF compliant, but it allows me to insert custom data as I need. And then for the industrial side, which is really where we're focusing our efforts from an HP standpoint, is we need to make sure that we can track everything, and we need to make sure we can make very large platforms with lots of parts in them reasonable and easy for applications to consume. So, as I mentioned, we have open source for the core and material specifications today. It's all on GitHub. There's reading and writing. There's examples and documentation for how to use the code. It's cross-platform. It's mostly C++ at this point in time. There's porting efforts going on right now to make it Mac compatible. It's actually Linux compatible today. There is a set of files already out there that are sort of must pass, must fail, and I think there's about 100 files out there today already, and we're growing that all the time. And then really what we want to do is continue down the path and provide more language bindings. So there's, in fact, I just looked about a week ago, there's actually at least 4 other projects in GitHub today that are doing a 3MF implementation that are open source. I haven't looked at any of them, so I don't know if they're terrible or if they're great, but there's definitely an increase in interest and an increase in traffic around people starting to build out other applications and other code bases to support this. Okay, so that wasn't technical enough, so I'm just going to blow through this. So as I said before, because of the way the mesh is represented, it has to be manifold, and it has to basically, it ensures that normals are facing in the right direction. And that's all I'll say about it, because if you want more technical information, come see me afterwards, and I'll tell you all about it. For material, I'll spend a little more time on this because I think it's important. So in the material and texture extension that's already been ratified and is actually more part of the core, it's been around for about a year. You can do base materials, base color, or vertex color. You can do texture bitmaps, and you can actually create composite materials very easily. And then you just reference those materials from your geometry. So it's very compact. If you're creating multiple channels, you do have to create those as composite materials, and then you have to reference them individually. So if you have a lot of different properties, etc., it can get a little bit complicated, but it's still far simpler than having to reference each one of those properties or materials in an individual basis from every single vertex in the part. Okay, so how to use 3MF. If you're a developer, a content developer, please start looking at the specifications in the code so you can export to 3MF instead of exporting to STL. There's plenty of support if you go look at what's available on GitHub to help you get started, to kind of bootstrap you into doing that. I think what you'll find is that as you start to use it, it becomes much simpler, because your ability to, or the need for you to do a lot of fixing and sort of fix-up should be greatly diminished, just because of the way the libraries are written and because of the way the format is specified. If you're in the middleware space, actually this is one area where we would really like to get more people sort of in the mix. So we envision an ecosystem where we have a lot of services and applications sort of supporting the additive manufacturing workflow, and some of those will be in the cloud, some of those will be within factories, some of them will be within enterprises. But as we start to build out sort of both ends of the system, where we have good support from a design application perspective and good support from a hardware perspective, then we need to be able to kind of fill that middle gap. So we have good representation today, but what I've been seeing just recently is I've been getting hit by lots of people who are in that space trying to figure out how to both build good geometry and how to represent the geometry that they're getting in a better way, and also how to then send that along to other workflows. And then if you're in the 3D hardware space, we'd love to have as many hardware platforms, obviously, as possible supporting the standard. With the new slice extension, we believe it's actually suitable for most hardware, not all hardware, because it's not a toolpath, so maybe not FDM. But for anything beyond FTM, we believe we can actually support most of the hardware pretty well. And if not, come to the consortium and let's figure out how we can actually drive those extensions into the standard. Okay, so summary. So we are an industry consortium. Right now we have 15 members that represent the entire range of the 3D printing industry. Our intent is to support the manufacturing workflow. We don't do design, we don't do rendering, but we want to make sure that we've got a solid representation of geometry and metadata to drive manufacturing from design all the way to hardware. We want to make sure that we're eliminating barriers to entry and getting people bootstrapped as much as possible, and all of that is just really around driving adoption. And what we really would like to see is 5 years from now that we don't really talk about STL anymore, that we've sort of moved beyond it. Or maybe it takes 10 years, but the intent is to start to clean up this whole ecosystem, because right now a lot of the infrastructure that's in place to support 3D printing is in place simply because we have to deal with content that is not complete and not well formatted. So I think that's it. So thank you very much for listening, and if you have questions, let me know.